So make sure that the partner that you're with is a partner that will take you either to this level or to that level, right? So everybody is happy with your partner, right? You chose yourself.
This activity is called Silent Partners. Silent Partners is a formative assessment strategy that evaluates students' mastery of mathematics procedures. It gives teachers a clear view of students' misunderstandings before a test, providing them a chance to see what topics they need to reteach. It is also a great review activity before an exam. Students are given whiteboards and dry erase markers to solve a series of tiered problems. They're grouped in pairs to solve those problems together with only one condition. They cannot talk to each other. It's a silent activity. The students take turns with each step until they successfully complete the problem. If one of the students makes a mistake, the partner clarifies and corrects that mistake until both can solve the problem. Students get two handouts, one with solution hints and the other with a checklist where students assess their own and their peers' mathematical behaviors. Both handouts are in agreement with the selected Common Core, practice, and content standards. Why is this strategy successful? It's simple. Because silence is golden. Yes, this is a cliche, but it works. First of all, Silent Partners divides a numerous group of students in half, providing a more focused view of student work. Silent Partners keeps all students engaged and accountable and committed to each other's progress. It also optimizes the time teachers spend in effective formative assessment. So what if partners can't solve a problem? What if they're both stuck? What happens if both students have the same mistake? Well, the teacher walks around and documents any observations. Teachers can also address individual groups and help struggling pairs by pointing out and clarifying misunderstandings. Students receive immediate feedback on their work. Silent Partners is also a way for the teacher to identify mistakes prior to students being tested and reteach right after. But here's what is key. Keep this activity brief, no more than 15 minutes, and follow it with a debrief. When the teacher stops the activity, he or she should allow students to express any challenges or misunderstandings and then plunge into the next teaching phase. Here's what I learned.
And I saw it in this team and I saw it in these two teams, and evidently you had the same confusion. You thought that this was subtracting.
We could learn each other's mistakes.
You can learn from each other's mistakes. What happens specifically that you're telling me that?
Like sometimes we have arguments. Like we decide to change.
So you were fighting?
Not fighting, but we were saying
nice arguments, nice academic arguments. Yeah. And what happened? Who was right or who was wrong?
We were both wrong, and sometimes, but then we were right, and the others.
So you were both wrong. And how did you discover that the right answer? If you were both wrong, how did you figure out that you were both wrong?
Because we were seeing the examples you gave us over here, so we saw it was wrong. So we were thinking from the sign, the little sign, we were thinking it was the other way to put the line, but it was the other way, and we used to think both of us used to think that it was one way, but it was actually the other one.
I saw that a lot of the teams struggled. You saw the inequality, you got to the right answer, but when you came to the graph, you didn't know if the arrow should point this way or that way. Am I right?
Yeah.
So
this is the greatest strength of this strategy. The teacher can identify the mistakes and misunderstandings students are having over and over again, and then address those mistakes promptly to make sure students get past them and master the procedure. To help clear up some of those misunderstandings, technology allows for further clarification. It helps all kinds of learners, especially those with highly visual and kinesthetic learning styles that need to interact with mathematical concepts. In this example, students are given an inequality which we already know they can solve. The challenge now is to graph it.
place your cursor or your pointer in a place where you have the solution to that inequality. Show me in a number line a place where this is the solution. Everybody, go there, go there, go there. So let's analyze what is happening. Is everybody right?
No.
Come and show me all the people that are wrong. That's one. Where did that negative answer come from? What I do know that happened over here is that this person probably put something like that. So if we want to make a graph, let's see what you did Nice with your cursors. I will do it right here. And bloom. All these numbers are my solution, right?